are you?
Good. So I figured out how to do this.
Okay, let me find it.
It's not easy.
I'm sorry.
No, that's fine. This is one of the more enjoyable problems I've ever figured out because it was not easy.
Oh. Okay.
I'm not going to go through it statement and reason by statement and reason because I'm sure you have a lot of other stuff you'd like to cover. Your finals probably tomorrow?
Yeah.
Okay. Did you send me anything, by the way?
I did. I don't know if it has sent from me yet, so I can check.
Yeah, I have it.
Okay.
Now, since we only have a half an hour, let me make this really quick.
Okay.
The reason this gave me so much trouble was I thought it was a 3D problem. And it's not. It's a two-dimensional problem.
Oh.
Notice, if you look at triangle JKL, what is FE in that triangle?
It's a median?
Mid-segment.
Oh.
Mid-segment because it bisects both sides. It bisects JL and it bisects KL. And any mid-segment of a triangle is half the base. So we know right off the get-go that EF is equal to half of JK. Now look at FG and look at triangle LKM. What is FG in that triangle?
A mid-segment?
Therefore, it's equal to half of LM. Well, LM is the same as JK. Therefore, we've just proven that EF is equal to FG. Now, if we look at line GH, the next two steps are a little harder to see, but not really. If we look at line GH, that's the mid-segment of triangle JKM. Whose base is JK. In other words, that, because it's a mid-segment, is equal to half of JK. And the only other triangle there is, or line there is, in that figure is EH. And focus on triangle LJM. EH is what with that triangle?
It would be a mid-segment.
Therefore, it would be half of LM. Since LM is equal to JK, all four of these are equal to one another because they are all equal to either half of KJ or half of LM. That makes it a rhombus.
Okay.
Now, there's 12 statements in there because you have to, use substitution. In other words, if that's equal to half of that and that's equal to that, then that's equal to half of that also. So formal proof is still a little bit of a task, but on problems like this, you always have to figure out how you're going to prove it first. And this is merely 4 triangles that are two-dimensional triangles. And each one of these lines is a mid-segment on one of those 4 triangles.
Okay.
Okay? All right. Where should we start here?
We can start at the top.
Okay. Give me an equation that's going to allow me to solve for x. ST is 3x plus 5, right?
Mm-hmm.
I know I got to solve for x. So what equation will solve for x?
You could do 7x minus 8 equals 3x, or plus 3x plus 5 equals 8x plus 9.
Perfect. We won't go through the math because I want to make sure we get as many of these covered as possible. But
Mm-hmm.
I know you don't have any trouble with the algebra here.
Yeah.
So once you solve for x, substitute it into 3x plus 5, and you'll have the measurement of st. Okay?
Okay.
Let's look at 2. Give me an equation that I can, again, solve for x. Because in order to know what this ABC angle is, I'm going to have to solve for x.
You could do 5x plus 2 equals 7x plus 6.
That will get you a solution for x, and then you'll know their answer.
Okay.
Okay, let's go to 3. The midpoint they give you, and they give you one end point. And what they're asking for is the other end point. Now, I find it helpful on these to draw a picture and label the midpoint, -1, -2. Label one of the endpoints, 4, 4. Connect them. And way down here is another endpoint. What is it, and how do you figure it out?
I do not know.
Well, midpoints are always halfway between the x-coordinates, right?
Mm-hmm.
And the midpoint, the y-coordinate of the midpoint is halfway between the y-coordinates.
Mm-hmm.
So how far is it from 4 to -1?
5.
So how far do I need to go in the same direction to get to my other endpoint?
You need to go -5 from -1.
Which gives you?
-6.
Yeah, and we can verify that immediately. That -1 is the midpoint between -6 and 4. Remember how we find midpoints? We add the two numbers and divide by 2. But
Mm-hmm.
the real way we find midpoint is it's halfway in between. So whatever's halfway in between, however you can find it, that's what you should do.
Okay.
Use that little formula or not, you know how to find halfway in between 2 points and the other way. So let's look at the y-coordinates. What's this new y-coordinate got to be down here?
It would have to be -8.
Good, very good, Allie. That's how you do it when they give you one end point and they give you the midpoint. Is you basically extrapolate to find out where the other end point has to be, knowing that the midpoint is halfway between the two endpoints on both the x-axis and the y-axis. The easier question is if they give you the two endpoints and they ask you the midpoint, right?
Mm-hmm.
That's really easy. Then you just have to find what's halfway in between. So this is a little harder conceptually when they give you one endpoint and a midpoint. The reason I like to draw a picture of it is because you can at least know you're in the ballpark when you come up with an answer. If you came up with an answer of +6 -8, you'd see immediately you made a mistake.
Mm-hmm.
So having a picture on these kind of questions doesn't hurt. All right, hold on. Number 4. What's my equation?
It would be 9x minus 12 plus 24x plus 60 equals 180.
Good. And then that will allow you again to solve for x. And you have to substitute it into both of them to figure out which is the smaller angle. Although it's pretty clear that A has to be the smaller angle, since it's 9 times x minus 12, and this is 24 times x plus 60. So there's no question that B is going to be bigger than A. But you have to solve for x and determine that, however you determine it. You could determine it by looking at it, or you could determine it by plugging it into both of them, figuring out which one was the bigger one. So one thing we've never talked a lot about is the naming convention on triangles. Let's talk about that for just a second. There's been a few problems that I've run into with my other Jan Stack student who is in honors geometry that requires you to understand these naming conventions. In other words, this has to be W. I could not make W any other angle but this. That has to be R, that has to be D. And by naming it in such a way as they did, I identify corresponding parts. In other words, now I know that AP is the corresponding side to RW. Not because of the way I've drawn it, because this can end up being rotated so that you would have a hard time recognizing. And if all three angles were close to the same, you'd have a hard time recognizing which was the smallest or largest side. So the only way that I know that PA is congruent, is similar to WR is the naming convention. This is triangle PAS. This is triangle WRD. You know what I'm saying? Okay. So they say that AS, it was congruent. Sorry. It was congruent the whole time, not similar. Doesn't really matter. The same principle exactly holds for similar triangles as well as congruent triangles. The naming convention identifies which sides are the corresponding side. So they're saying AS is congruent to RD, which we can tell from our picture that because of the way we drew it. But which reason of the multiple choice that they give is the reason?
Would it be CPCTC?
Yes.
Okay.
Certainly isn't this, because they told us the triangles were congruent. These kind of things are used to prove congruency.
Yeah.
Reflexive means something is equal to itself. Transitive means something else, but CPCTC means corresponding parts of congruent triangles are congruent. And AS and RD are corresponding parts.
Okay.
Give me the equation on number 6.
You do 4x minus 8 plus 64 equals 180.
Good. And the equation on number 7.
2x plus 1 plus 2x plus 3 plus 3x plus 1 equals 180.
Good. Number 8. You want us to determine the x and y values. What's x? First of all, this line right here, what's it called?
Oh no.
Segment.
Yeah.
Okay, because it bisects both sides. It bisects that side and it bisects this side. That, by definition, makes it a midsegment. How does it compare to the length of the triangle, the base, which is x?
Well, it's half.
Okay, so what does that make x?
60.
Okay. So now let's talk about angle y. X is a side length, but y is an angle.
Mm-hmm.
What do you know about y?
Well, is it like, it's linear to the angle on the opposite side of it?
Well, it is. Not sure that helps because I don't know this angle over here.
Well, that angle would be 65.
Ah, okay. So let's do it that way. In other words, that angle is 65. Why do you say that?
Because I think we have a theorem that says if there's the line segment, then it would be parallel.
Well,
Or I could be wrong.
not. I think this is a typo and they meant to tell you that they were parallel. And the reason I say that is because if you can ever draw a picture that clearly they're not parallel, and yet that thing can still bisect both sides. In other words, that's bisected and this is bisected. And this mid-segment is not parallel to the base. I believe that it is still half the base. So I think even if, in other words, they don't put parallel signs here and they don't tell you that that's a trapezoid, so we don't really have any reason to believe that this mid-segment is parallel to that. I don't think it has to be. I believe you can draw it the way I've drawn it. I know you can, because what if I had a triangle like this, and I said, okay, I'm going to bisect that line, and I'm going to bisect that line, and I'm going to connect the two. Does that make it parallel to that? Gosh, sure looks like it, doesn't it? But hold on, let me see if I can draw this in a slightly different way. Draw it like this. And then I want this line to definitely not be parallel. Now, doesn't there have to be a point there? But that point is not necessarily. Yeah, now I may know that that's equal to that. The question is it possible for that to be equal to that? Maybe not. In other words, when you end up bisecting both sides, it may by definition mean that those are parallel. And if they are parallel, then you know that this angle is 65, and that's 107, and that's what y would be 107. and that's surely what y is. In other words, they don't give you very many choices here. It's either 73, you know x is 60 for sure, and so y is either 73 or 107, and you could look at it and see that it's not 73. So this is one that you could actually just inspect if you were in a hurry and didn't want to go through the math. You know y would be 107 if given just two choices.
Yeah.
But the more I think about this, the more I think that if this line bisects that triangle, it probably is parallel. Because I'm not sure you'd be able to solve this problem if it didn't. In other words, if I was able to draw this at various angles, let's say that I drew it at this angle, well, it doesn't bisect both sides now. There's no way the blue can bisect both sides and the black also.
Yeah.
I'm beginning to think I'm just not remembering one of the theorems regarding midsegments, that if a line is a midsegment, it not only bisects each side of the triangle, but it's also parallel to the base and equal to 1/2 the base. So that should be the four things associated with midsegments.
Yeah.
All right, and the triangle to the right, the shortest side is?
It would be A would be the shortest side.
Yes. How'd you know?
Because 54 is the smallest angle, and those two are.
How do you know 54 is the smallest angle?
Because you can.
Did you solve for the third angle?
You can, but I'm just kind of guessing.
How'd you know that it was? In other words, I had to solve for this to know that it was 61.
Well, I just kind of put it in my brain. It was like 64 plus 54 is 118, and nothing can be smaller than 60 from that.
Okay, that's good. That's all you needed. You don't need to know that it's 60 whatever. You just need to know that if that first digit is a 6, then that's the smallest angle, and therefore that's the smallest side. And that's always true about triangles, is the smallest side is always opposite the smallest angle, and the largest side is always opposite the largest angle. What's the largest side?
64. I'm gonna guess C.
Well, don't guess.
Okay, I'll actually do the math.
In other words, this is a little harder because that first digit is 6. And when the first digit is 6, you can't automatically assume that 64 is the largest, right?
Yeah.
It was enough to assume that 54 was the smallest, but it's not enough to assume that that angle is not bigger than 64.
It would be C then.
Well, no. If you figure out that angle, that's the first step of this problem, is to figure out this third angle. Okay, and that third angle comes out to be 62, excuse me. So A is definitely the smallest, and C is the largest, and B is the middle side. But you don't really know any of those until you solve for this one. In other words, you can't really do this one graphically. Even though they've drawn this pretty good to scale, and you could almost see that the 54-degree angle has to be the smallest one, figuring out the largest one is a little more difficult. It's not quite as clear, at least not to me, that 64 is the largest one. Until I solve for that and get 62, then I know it is. All right. Well, I think you're in pretty good shape to take this final. What are you getting in the class before the final?
Right now I have a 71, so not very good.
Well,
I just have to get a C on the multiple choice final, and I'll still have a C in the class.
yeah, I'm a little shocked because you seem to know this stuff pretty well. Somebody would have made me bet what your grade was, I would say at least 80 or more.
Nope. He's a really hard grader, and I just screw up on random things, so he takes off some of the
We
points.
went through this review material and you didn't even come close to having a hiccup. You got every one of them right perfectly. Now,
Hmm.
granted, we didn't solve all of them. In other words, is all I did was have you set up the equations. But
Yeah.
I don't see that as being a weakness of yours. Solving
Hmm.
simple linear equations, you're pretty comfortable with that, aren't you?
Hmm.
That's not where you
Oh,
make your mistakes, is that correct?
no, it's normally like written problems I don't do well on.
Okay, okay.
It's just not something I can do. And also memorizing theorems I'm not very good on.
Hmm.
There's a lot of them.
All right. Okay, well, I will let you go. I'm sure you will not have any trouble getting a C on that test. Is there any score you can get that would raise you to a B?
I have to get like a 99 to get a B.
Oh, wow. Well, that might be
So,
tough, but I don't know. You would have gotten a 99 on these questions.
yeah, but,
You'd have gotten every one of them. You'd have gotten 100, assuming you were able to do all of the algebra equations, right?
hmm
So there's hope, maybe.
hopefully.
All right, Allie. I'm assuming that we probably do not have a session for the next few weeks.
I don't think so.
Okay. I will take you out of there. You're certainly not going to want one 2 days after Christmas.
Yeah.
If you guys want to start up for some reason early just to refresh your algebra skills or something, or get a head start on next semester's geometry, let me know.
hmm
I'll be around the whole holidays. Only 2 days I won't be available is Christmas Day and New Year's Day.
Okay.
If you would like to schedule something in that period of time, feel free to email me or go on directly on my website and schedule it. You
Okay.
always can do that.
Okay.
Okay. Well, good luck to you. You have a good Christmas. Good luck on your test, and I'll probably talk to you next semester.
Okay. Thank you.
All right. You're welcome. Bye-bye.
Bye.